Hi, everyone. So this is problem-solving recipes learned from supporting Spark. I am Justin Pihony, the developer support manager at Lightbend, and my colleague Stavros, who is one of the engineers on our fast data platform, which includes Spark. So this talk will wrap all of that up for you, kind of everything we've learned from supporting Spark, as it says. So if you're here and you're using Spark, you're new to Spark, you've used it and you've run into problems, this will have a wide range from beginner to potentially advanced. Hopefully, everybody will learn at least one new tidbit out of it. Just a reminder, please use the Scala Days app to rate the session. And like we said, this is more like a recipe book, so we're going to set things up as a book. So as far as the contents go, the first thing we're going to have is the section on out of memory. So it's big data. We're going to be dealing with out of memory more and more often, so we're going to give you some areas of common problem and how to work with them. No such method, basically kind of a class loader type thing more, but I won't give too much away. But again, the goal of the table of contents is to let you know upfront what you're getting into, what we're going to cover, and feel free to, if none of it interests you, feel free to check out another session. The other one is Perplexities of Size, kind of figuring out what the right size of to work with for your blocks of data. Then we've got struggles in speculation. So Spark has a speculation mode, and we'll kind of cover. Just turning it on blindly doesn't always work, so we'll give you some ideas behind that. Strategizing your joins. So joins are a natural thing of SQL, and you have Spark SQL. So they result in big data with big data, which makes oftentimes a boom. So we'll kind of cover some of those areas there, as well as dealing with stream recovery and how to handle it safely. That's dealing with D streams, not necessarily with structured streaming. And handling S3 without hanging. That one, I think the title gives it away, and we're good there. So as far as the prologue, like I said, we're both from Lightbend. We provide support for our customers, and one of those areas is Spark, as well as I am active in the Stack Overflow community. I think I'm number 5 for Stack Overflow Spark questions right now. And I do a bunch of teaching around Spark for Pluralsight. I actually have a course coming out soon. So that's kind of the credentials on how we've amassed these recipes. So that said, I will hand off to my colleague, Stavros.
So, first recipe is about memory problems. Obviously, not only Dory has memory issues, also your Spark jobs may have. Out of memory error in JVM is quite well known. You get it when your garbage collector cannot get you any more memory for your program. And this in a Spark application can happen in at least 2 areas. Like one of them is your driver program, and the other one is at the executor side. Now, you have to know a bit about the memory layout for Spark jobs to understand what is happening. So, of course, you can tune things so you don't get these out-of-memory errors. But let me first explain a bit what is happening and why at the end you shouldn't really try to tune it. Now, at the execution side of a Spark job, your memory is split basically in 2 areas. One of them is for execution and storage, and the rest of it is for user data structures and also for safeguarding against these out-of-memory errors. So for the first part, which is for execution and storage, and which is defined by this first property shown here, the Spark memory fraction thing. You get like 2 parts, and by default, this is 60% of your whole heap memory. Now, in these 2 parts, you have one for storage, as I said, and the other one is for execution. And these 2 parts fight with each other to get as much memory as they can. Now, the other parameter there, the storage fraction parameter, provides a safe area for storage so that any memory block there cannot be evicted and cannot be claimed by the execution part. I said all these details because if you start playing with this, you have to watch out for certain things. Now, the default values should work well, but if you try to play with this, just make sure you give enough memory for execution and storage as well. For example, there are cases where you may want to cache data and you give a lot of memory to storage, but it's possible that runtime that you load some big record or some data partition, and then you get this out-of-memory issue. And the other thing is you should be aware of garbage collection issues, and you should make sure that all your cache data fits within the old generation space. So these are the details about high-level details about memory management in Spark, and you understand that this is a quite complex thing. So if you're trying to tune things, you should better think about all the details. Now, before even jumping into tuning all these parameters, there is a project called SparkLint that could help you with that, and so you can make better decisions and find out if you really want to go with tuning stuff. One other thing that we have seen with customers, and it happens always when you develop something, you have to make sure your runtime memory use. You have to be sure that you don't create too many objects and too many big objects, because this may also end up with some problems with memory. Now, oops. Okay. Now, in Spark, you have three APIs you can use for your jobs, and the 3 of them have different characteristics in terms of memory. You have RDDs, data frames, as you all know, and data sets. Now, there's a nice article from Databricks about all these APIs and their different use cases where you can use them and why you should go with one of them or the other. The basic thing about relating to memory is that datasets and data frames can optimize your memory use. If you can really use them for your use case, you better go with them because they get advantage of the tungsten memory engine in Spark. So all your objects are encoded and they are optimized for memory use. And there is a big difference in memory footprint compared to RDDs. This comes from another ticket from our customers. So quite often people ask how can calculate my resources that I need for my Spark jobs. And this is highly dependent on the environment you're going to run things. So as always, for all these frameworks for big data, you need to know the execution model. This is pretty basic. So this customer wanted to know how he can calculate his resources for his Spark job on a Yarn cluster. And this is This is something that you have to calculate at least manually for the worst of the cases. And there are a lot of guides out there for how to do it. So basically, for yarn, for example, you have to take into consideration how things are going to run. If you're going to run in client or cluster mode, to dive a bit into this case, for example, in yarn, everything runs in a container. So if you choose to go with cluster mode, your Spark driver will run within the application manager. So eventually, you have to think about what size the Spark driver is going to be in terms of memory. So you have to have enough resources on the node it's going to run, so you can you don't end up again with out-of-memory issues. Now, if you go with client mode, it's going to be less resilient, but it's going to be more lighter in terms of memory again. There are cluster-wide parameters you can tune to define the resources you're going to allocate for your Spark jobs. There's a big list about them. And also there are specific Spark parameters to tune your resource usage for your Spark jobs. The end goal here is simply to find out how many executors you can run on your cluster, and at the end, how many partitions you can have for your Spark jobs. This is important. Let's see an example. For example, if you have a memory-oriented Spark job, eventually you want your cache data to fit within your executors. Let's say you have one executor and this runs on top of 4 cores. Then what's going to happen is you are going to have 4 partitions which map to 4 tasks in Spark, and these 4 partitions should actually fit within the Spark executor memory. If they don't, you will have, again, out-of-memory problems. There is a nice talk at the previous Spark Summit. It's titled Spark Auto-Tuning. It discusses a lot these issues for yarn, so I advise you to have a look at it. The next thing about out-of-memory issues is what we see often is that people, they want to do something quite reasonable, like they want to report something, and they want to gather all the data to one partition, and this, again, ends up with problems. Justin?
Okay. All right, so the next thing is no such method. So everybody generally probably knows the key items here are with a no such method is that the class, that's not working, the class no longer has a definition, and but this happens at runtime. Otherwise, you normally would get a compiler error, but at runtime, you end up with the class not having the definition of the class, or it's kind of an incompatibility change. So let's see the specific use case that we saw here. This is based around a mathArrays.natural, kind of a math3 thing. It's going to be a specific case, but this carries across no matter what. So the specific thing that happened here in the case was Spark. So again, this is kind of dated, but again, the generality of it still holds even in Spark 2.1.1, I think it is. So Spark 1.4.1 uses math3 3.1.1, which, as it turns out, doesn't have the natural method. So they're trying to use the natural method, and this is custom code that they had. As far as they knew, everything would be fine. They wrote their code, and they pulled in the dependency that for their own code to say use natural. Turns out that Spark was using a different version. So you run into a dependency collision. You compile it against version A, but your runtime is using version B. The runtime in this case happens to be Spark. So Spark says, hey, like we said, it's using math 3.1.1, doesn't have it, even though you compiled against an older version. I've loaded a different version. I think in this case it was a older version. So again, version B did not have the method. So how do we deal with this? There's a number of solutions that we have here. You can upgrade Spark or downgrade your library, but that's if you're lucky. I mean, you might need to use that natural, and you can't downgrade because you need natural, and maybe there's something in your organization that just makes it really hard to upgrade, so you can't get Spark upgraded. So that's more if you're lucky. So the next thing you could try is enforcing the library load order. So you can focus on this driver class path and put in your own Commons Math 3.3, Math 3.3. So it'll force the library to use that 3.3 jar. The only thing that you have to kind of think about there is now you're using 3.3. You potentially could break Spark. So probably a good rule of thumb is if you're in a minor version change, then you're probably okay. But it's still something you want to keep in the back of your head. The other thing, and this one is kind of it takes a little bit more work, but not even that much, is you could shade your library. SBT has documentation on shading, and Maven has a plugin to help you handle that. So basically what it's going to do is say, well, you're using 3.3, Spark's using 3.1, so whenever you compile with 3.3, we're going to basically kind of rename stuff so that it doesn't seem like it's the same library, and you can essentially have both loaded. It adds a certain amount of complexity into it, but it solves your problem without having to really deal with upgrading, downgrading, and stuff like that. So the next thing we have here is Perplexities of Size. This one's more of a general recipe. So it gets to kind of the Goldilocks. You want your size to be not too big, not too small. You want it kind of to be just right. So the problem is if it is too small, then you end up too much overhead. So you're going to end up spinning up all these executors that it takes a lot to spin them up, and then they do almost no work, spin down, and it's going to keep repeating, and you're going to just keep spending most of your time on executor time. The other time is if it's too big, then you end up with executor skew, where you have idle resources sitting out because you've put so much onto one core and the other one is just sitting there. So like I said, you kind of want to have a just right size. So what you can do is kind of follow the rule of thumb that is used for HDFS and have a generic block size. They have, I think, 256 kilobytes for their block size. But the one thing that you can do, as far as kind of looking through it, is you can look for your median. No, it's just not showing up. There we go. Okay, so you can have your median versus your max. So you can take a look at those durations. And if your median is about, I think it's 5x more, or your max is 5x more than your median, then you've got a problem. And at that point, you can take a look at the task list here and try to find maybe if there's a specific core or something that's going wrong. The other thing as far as size goes, just to kind of double back on that, is in general, what you're shooting for is 2 to 3 times your number of cores, because the focus whenever you're going through all this is to maximize your parallelism. So that, I mean, again, Spark is distributed, so you want to maximize how much work it's able to take, but not have too much on overhead. So overhead would be shown as maybe a bunch of tasks, all with pretty much 0 time. And then if the other way, it'd be like a 30-second task that runs. So the rule of thumb, like I said, 2 to 3 times your cores. But you can also get away with 4 to 5 times if you have like large computations that are potentially happening, maybe machine learning, things like that. So that said, I'm back off.
Okay, so as in life, someone may be faster than you, but at the end of the day, this is not something you want to happen with your tasks. Because if a task is slower than the other, then it's going to hold your job for finishing on time. So this recipe comes from, again, from another ticket we had with a customer who had this huge cluster with like thousands of cores. And what happened was that when they ran their job, there was a network issue, some faulty network card that was delaying a specific task from the job. And this was important because it was keeping the job from finishing, and also it didn't allow other jobs to run, and because most of the cores were used by that slow job. So what we propose there is to try to trigger this speculation feature. Spark has this speculation feature which allows you to find out the task that is causing the problem and then relaunch it on some other node, so your job can finish on time. So there are some parameters there that can help you actually do this. So there is one for which is called the Spark speculation interval, which allows you to say how often the Spark should look for Spark task being late. The other one is the multiplier parameter, which says how slower a task should be from the median to be considered for speculation. And you have the third one, which is the quantile, which says what fraction of tasks should be complete before the Spark should even consider speculation to be triggered. What we said to the customer is that you can increase the quantile part, because this is by default 75%. You can increase it to 95% because you know they're going to have some problem with your network or something, because from a statistical perspective, in huge clusters, you always get these hardware issues or whatever. So you know you're going to have it more or less, so increase that percentage and make sure that the task that's slow is going to be relaunched. Make sure that this task will take no more than the rest. Let's say if you increase the quantile to 95%, the rest is going to be within the rest 5%. And you want to hide this delay within the normal tasks, so you can avoid at the end having the same problem of delaying your job. That was the story with speculation. The next thing, again, this comes from our ticket base, is joins. Joins cannot be avoided, actually. It's something you always need. It's in SQL databases, also in big data, also in Spark. So it's common case that you have a slow join. Now, there are certain cases that you can avoid that. One of them is when you have a large data frame and a small one. Now, this can happen. This can happen in many cases, and also we see that with customers. And there is some primitive you can use, a broadcast primitive, so you can broadcast your small data frame, so it's not going to be reloaded again and again. But you have to be careful and use the explain call on your data frame, so you can make sure you have the correct physical plan chosen by Spark. If not, you are not going to get your optimization. Now in Spark, there are several strategies. The one is broadcast, the one I just mentioned, which can be tuned with this auto broadcast join threshold, so you can say how big should be this small data frame. There's also shuffle hash join, which I think was removed from Spark 2, and the default one, which is a short merge one, and which is the optimized strategy used in most of the cases. Now, about the broadcast strategy, there are some more parameters to use. The Spark, there is the Spark broadcast timeout, which gives you some, where you can tune how much time you have for the broadcasting. The block size, what size you should have for your small data frame. Now here you should be careful and not pick something that it's over 2 gigabytes, because this will cause Spark to fail. You should have big enough block sizes to make this work. And there are cases where you cannot avoid joins. For example, in this case with this aggregation operation, you may have more columns than we saw here, and you are going to lose the information if you do such a operation, and you will have only the fields you reference. So if we had more fields there, like another column besides the 3 ones, then you're going to lose it as the result of this group by and aggregation operation. The only way to regain your columns or fields, whatever, is again to do a join. So these are some limitations you get with data frames.
All right, so safe stream recovery. So this recipe is based on a case where we had a customer who was using Spark streaming. So again, this is not necessarily the newer structured streaming, which is still, I believe, still in beta, or is it alpha? I think it's beta. So it's released, but it's still not 100% for production, I don't think. So if you are still using Spark streaming, then we have this case here where they're loading in a Cassandra table. So this is outside of their stream. They're loading in this Cassandra table, they're mapping it, changing it, whatever, and then caching it. And then they run their stream. They say orders transform, and inside of there, they're running a join. So they take their inner RDD inside of the order stream and join it to this products RDD that they loaded outside of the stream. So all of that's fine. It's going to run, and everything's going to work. And then whenever it crashes, it's going to start back up. It's going to try to read off of a checkpoint, and it's going to fail, even though it was working, right? So what's the problem here? You're going to end up with this weird error. RDD transformations and actions can only be invoked by the driver, not inside of other transformations. But it was working before. You're not doing anything inside of the driver. What's going on? It gets to a problem with the way that checkpoint recovery works. So the problem here ends up being that you're using this product which was built outside of the stream itself. So how can we fix that? The simple way to fix it is to actually, you're given the RDD. So once you're given the RDD, you can call the Spark context from there, load your Cassandra table, do your mapping inside of there, basically load the products inside of your transformation. But And so, again, that works. But remember, there was one thing that we had to add there, and they had caching for optimization. That's one of Spark's big things is, okay, well, you can load your stuff in memory, and especially in this case, you're constantly going through loading this and that, and so you know that you only need to load this once, so why can't we just cache it and be done with it rather than constantly taking the hit of going to Cassandra, Cassandra, Cassandra. So let's see how we solve that problem. So that problem is we're going to first, inside of our transformation, we're going to say, give me the persistent RDD. So that's basically give me everything that's been cached. Filter it on some name. I mean, we just have it being foo, and give me the top one. So, I mean, realistically, I do head options just to make sure that you're safe. But you should just have one. You shouldn't, if you're already filtering down to one, so you can say, just give me that first one. Now, once you have that, then you have to filter it, or you have to use a match to basically filter between whether that's been cached or not. So what you can do here is, if you get a sum with that persisted RDD, then we know that we've already loaded that Cassandra RDD. And what we can do at that point is it's stored as just a generic RDD. So you pass it as instance of whatever the RDD type is. If RDD works, then that's fine. But if you need it to specifically be a Cassandra RDD, then you can pass it back as this Cassandra table scanned RDD. So now the first case where it hasn't been run, it hasn't been cached yet, you get a none, and you basically just do the same thing where you say that you're going to load it in, Cassandra table, map it, and then you're going to, don't forget to set name. So remember, we are filtering it by the name. So set the name of your RDD, and then whenever you cache it, then you can do that filter. So from there, you get everything that we had before, and now if it crashes, goes through checkpoint recovery, you don't get that weird error about transformation. I mean, even if they just fix the error, it might help the problem alone, at least figuring it out. So the last item that we have is, I believe it's the last, yeah, is handling S3 without hanging. So S3, we have this simple code that says, okay, we have our streaming context. We're going to call text file stream from an S3 bucket and print our lines out. Really simple, right? I mean, this thing should work really easily. So it doesn't, though, in some cases. So especially it gets weird. What happens is if you have a ton of files in that bucket, then what's going to happen, even though this is a streaming system, the S3 API is going to say, hey, I need all the files from that bucket, and then it'll start streaming once it starts pulling things in. But it says, give me all of that, and in the process of doing that, it's basically just going to time out or just seem like it hangs. So in this case, the solutions, there are solutions. I'll admit none of them are optimal, but there are solutions. You can kind of pace it with your script. So your bucket, you can have two buckets, basically. One that is kind of like, hey, this is where you put everything. And then you can say, okay, the bucket that the streaming API is reading from can have like 5 files. So you can say every time that you've lost a file, add a new one from your kind of cached bucket over there, and keep loading them and let Spark keep reading them in. You can write a custom S3N handler. It's basically the same thing as writing the script, except you've now written it as something that's plugged into your API. So those two are the same thing. It's just one is dealing with scripting it in S3, and it's more outside of the Spark system. And the S3N handler is more letting it happen within Spark itself, where you can actually stream things. You can do explicit file handling. In that case, there's a Stack Overflow question, and the slides should be online after for the link. But in that case, what you can do is actually, it gets to that S3N handler where you can say, okay, I want to say, you write some code that says, how many files are there, and then you can you can just get the list yourself and go one at a time, and again, whenever it comes to streaming, you hope that it's going to be fixed as best as you can, but again, not the case here. So another thing you could do is increase the heap. This is actually potentially your simplest solution, however, it doesn't scale. So if it works at first, that's great. But at a certain point, you might end up running to a case where increasing the heap's just not going to cut it. But you could try that as a first solution, and that way it has more buffer to work with. The last thing is you can complain to Amazon and see if they'll fix the API. I had heard that they were going to fix it. I haven't seen it come through yet, but maybe at some point this problem just goes away. We can take it off of the slides, and you can just use S3 without having to worry about it. So that's everything. But I mean, again, this is an ongoing. Spark's still growing. They've got structured streaming coming out. It's all things that are constantly, people are having problems. So one of the things that we have is at Lightbend, again, we provide support. So we're moving more towards a fast data platform support, but if you're looking for anything there, then that's something that we can provide. Or feel free just to email us and let us know your problems, and just so that we can kind of keep an ongoing list, and we might even be able to help you here and there. But otherwise, I tried to stay on Stack Overflow and stuff like that. So again, remember to rate the session. And thank you for coming, and there's our emails. And again, we're always looking to help. So like I said, I'm on Stack Overflow. Come see us if you're interested in getting a Lightbend subscription or something along those lines, or if you're interested in the fast data platform, as we're calling it. So kind of streaming things through and dealing with that. Are there any questions? So just to repeat the question, because I'm not sure if I got it all also. So you're running into kind of a garbage collection overhead, and you set the memory overhead, and that's how you're currently working on it, and you want to know if that's kind of the best way to deal with that. It's fair? Okay. In that case, so memory overhead, I mean, I'd say in that case, whatever works, it works, to be honest. So if it is working for you, then that's great. Whenever it comes to garbage collection, I'd say one of the things you could do is make sure that you're looking at your code. It gets to, if you're using a map and you're doing any object creation in there, then that's something you want to watch out for. That's why we had the slide on use map partitions, which gives you the whole thing, and you can create one object, and so that it doesn't constantly create, because that's usually the biggest thing with garbage collection problems, is that you're just constantly creating objects. So that's my first guess. But without seeing, in that case, I think without seeing the code, it's often more of a code thing, I think, than configuration. So again, if you're able to get away with a configuration, I'd say if it works, then that's great. But I would still maybe review your code and make sure that you're not running too much. And again, the Spark UI has garbage collection stats on it too, so you could kind of see if there's specific points where it's actually, like which task it might be having problems with or something like that. So without seeing the code, I think that's probably the most general answer I could give to it. Anything, is that good, Stavros? Anything you'd add to it? No. Okay. Any other questions? All right, well then, like I said, we'll be around, and you can come and talk to us after if need be. And like I said, if you're just looking to get into Spark, I'll tout my own Pluralsight course on Spark, and in probably a week or two, I should have a fast data course on streaming, including structured streaming and SQL. So if you're interested in that stuff, go ahead and give it a check. Thank you.